Yeah. Back again with the lesson. We'll continue from the last class as we are discussing the functional view. In that, we are discussing the security components, right? Security functional components we are discussing, and we'll step into the next one, that is a management functional group. Management functional group. The management functional group contains the system-wide management functions that may be used individually. Functional components management interfaces. It consists of the following functional components. Now, what actually the management functional group? Management functional group needs in all the ways, starting from, I can say like this. From IoT service stage to the wherever the processing stage is there, the management to the business processing is there, or virtual entities is there. In all the cases, the management functional group is needed. So we will see what are the functional components here, which is essential. The configuration functional component maintains the configuration of the functional components and the devices in an IoT. The component collects the current configuration of all the functional components and devices, stores it in a historical database, and compares the current and historical configurations. So this is a damn important in a management, how we can upgrade ourselves, whether our project is scalable or not. I can say like this, I have used one particular maybe a sensor and one functional component I can use. Adding up of a functional components, that is also a very much important thing. You can see best example I will tell you. Always the apps, whatever you are going to take, meanwhile in every frequent period of the time they will ask for an updates. Why they will ask for an updates means to add up the few functional features into that particular thing which can help more for a customer. How they will get that particular functional components with an existing functional components, whatever it's working on, making that as a directory, watching that particular, managing that. They will see what are the feedback on that particular functional components, and they'll verify that. And so new things can be added up according to the requirements. That is a one view. And another is the one is the change of an even devices components. So based on that, I can say like this, whatever is there in our database, it has been maintained a so and so product model, and the working nature of that, the capacity of that. Maybe in the next few months or a few years, the new components will come with the less cost and more accuracy and more working performance will be there. Then definitely we can change that. So that is the one important thing will be there. The fault functional component. What is this? The fault functional component detects, logs, isolates, and corrects the system-wide faults if possible. This is damn important that whenever after a deployment of our project in a real time, what are the faults it is there in our particular project. Some projects, what happens to in our view, in whatever the inputs we have given and all, it will shows it's a correct. Whenever the project goes into the reality and the customers start use that particular project, definitely there will be some fault functionalities or functional components will be there. It will detect that, locks it, means it will records that. And this is very much important. Recording automatically some services of a customer or a feedback, the logs, isolates, and corrects the system-wide faults. Always it will takes that, and every meanwhile, assume that every 15 days once or every 10 days once, it will be keep on correcting. So that is the one important thing which you can take. So that is a functional group. Wait, just a minute. Yeah, continuing with that, the member functional component manages. What is this member functional component? Manages the membership information about the relevant entities in an IoT system. Example, relevant entities are the FGs, that is functional groups, functional components, services, resources, devices, users, and applications. So regarding that memberships means how it can be taken, what is the parts which we have used and all in components, how many members are using that, and what are the how many applications are coming out of our particular project. That will be taken into the consideration. The state functional component is similar to the configuration of the functional components and collects and logs state information from the current functional components, which can be used for fault diagnosis, performance analysis, and prediction, as well as building purposes. So all these particular things, some functional components will be there just for an logs things. Always it will keep on logging the details whenever something goes wrong. When the device, meanwhile, every 10 minutes, the device should give an input or an data, but it's not giving the sensor. Sometimes it's not given frequently. Assume that in exactly the when more rainy season is there, the sensors is not working correctly. The data is entirely different from the regular data. It depends on your project. So how you are deploying your project and how your sensors, where sensors has been deployed. So that's the one thing. The reporting functional component is responsible for producing the compromised reports about the system state based on input from the functional component. Means every 10 days or every week I want a report that how my components, means how all the functional components are working, whether it's working correctly or not. So any variation is there in a functional components and all that we will take into the consideration. Now this ends the functional view. Now coming to the next, the information view. So in an information view, how we are going to view an information. So how the information will be taken from the data and the figures and the facts. So that we are going to discuss in this particular topic. The information view consists of what we are going to study. The description of the information handled in the IoT system. So what is the information which has been handled in that particular entire IoT system? The way this information is handled in the system, in other words, the information life cycle and flow. This is when the information is created, how it is processed, until what time the information is there, after the usage of what the information has to be deleted, until what time the information you should keep. So that this is another one important thing which will go. And the information handling components will also be, we are studying in this particular thing. Just a minute. Yeah, coming to the next thing. So information descriptions. Coming to the information view, right? Yeah, information description. The pieces of information handled by an IoT system complying to an architecture reference model such as IoT are the following. Now, what actually we always, you must keep in your mind that always we are following a reference model of IoT A, which is given by the ITU T. So, which has been given that. Now, coming to next, virtual entity context information. That is, the attributes as represented by parts of the IoT information model, attributes that have a values and metadata such as the temperature of a room. That you can take it as an example. The first thing what you must know with an information description. Virtual entity context information. What is my virtual entity? It's giving at that particular event or a particular time. That is very much important. That means at that particular state of a time, my entity is representing this state or this particular information. How I will get an information? The values to the attributes will be added by my real-time world, whatever sensors or actuators, tags, whatever is there, RFID tags and all, it will be added. IoT service output itself is another important part of information generated by the IoT system. Yeah, what a service I have defined and whether the output I am getting of that is correct or not. For example, this is the information generated by interrogating a sensor or a tag service. When I will switch on one particular sensor, either it will work or not. Best example I will tell you. See, I am doing a project for a restroom automation. What actually the customer has told me that whenever there will be a more smell in a restroom, the notification should be given to the housekeeping supervisor or a manager that in a campus in this number toilet is having a more smell. It should be cleaned. Assume this is a scenario of a project. Now, what I did, everyone, whenever it comes to the form of a smell and all, in our mind, automatically MQ will come into the picture. So, what is that? The MQ sensor will come into the picture. So, MQ6 I have taken, 7 I have taken, first 6 I have taken. For a prototype, and I kept in a restroom and I tried to note down the things. But even though there is, after the urinals and I'm telling frankly, all those things means it's not clean, the smell is there. I'm not getting an output. Means like that, what I mean to tell you that the smell detector, whatever is there of that MQ6, it's not working out. I got a doubt. What is this? Then I got to the Google and I Googled it that this particular sensor is meant for LPG, gas detection, methane, and toluene, benzene, like that. So this type of things. And then I got a doubt. Then what is a bathroom smell when it comes? What is a chemical component which will give the smell? So that doubt always sits arises. Alcohol, some part it will be there, but not regularly, not in a full sense. So what I did again, I gone for the MQ135. I thought. But MQ135 is purely for air quality sensor. What are air quality sensor? If air quality is not normal, it changes. So then it will give. I agreed. So some extent it will work particularly there. So I can keep this sensor I can take and I can work it out. So again, no, again, carbon monoxide, carbon footprints, it's giving, means Amit is doing this particular project. Amit, are you there here? Amit? 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 Amit?
Yes,
Who is
sir.
Amit?
What, sir?
Amit?
Yes, sir.
Which sensor you are using in your air pollution project?
MQ135, sir. Air quality, sir.
MQ?
35.
Sorry. MQ?
135, sir.
MQ135.
Yes, sir.
What MQ135? Which type of gases it will smells?
Because, sir, many gases, sir, just like, sir, carbon
Hmm.
monoxide, carbon
Hmm.
dioxide,
Hmm.
and, sir,
Carbon monoxide.
yes, sir.
Then
Then,
alcohol,
yeah, alcohol also, sir. Smoke also.
smoke. Yeah, good. So yeah, what he told is correct. Maybe Varsha. Varsha. Varsha is there. Varsha. Pradeep.
Yes, sir.
ವರ್ಷ ನೀವು ಯಾವ್ದು ಎಂ ಕ್ಯೂ ಸೆನ್ಸಾರ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
MQ2.
MQ2 ಯಾವ LPG LPG ಮತ್ತೆ ಇನ್ನೇನೇನ್ ಗ್ಯಾಸಸ್ ಸ್ಮೆಲ್ ಮಾಡುತ್ತೆ?
LPG, ಆಲ್ಕೋಹಾಲ್ ಮತ್ತೆ ಸ್ಮೋಕ್.
Yeah. So yeah, I told you. So even 135, even when I use it for my particular project purpose, it's not worked, frankly to say. So then I thought confused. So what actually I should use to get this particular things? Then I consulted the chemistry professor. Then the chemistry professor told very clearly that the two are the major components which will be there always in a restroom, in urinals, and as well as a flush, human the waste flush, whatever will be there. So in that, the main components are ammonia and then hydrogen sulfide. So then I got a doubt. And then I searched all the MQ sensors, which sensor will do this particular thing. Almost all MQ6, MQ2, regularly we are using MQ7 and MQ135. All these sensors doesn't have these two components. Then I tried in a better way. So I saw that MQ137 is a sensor which is specially used for an ammonia gas detector and ammonia and hydrogen sulfide. So then I got yes. So this is a sensor which I can implement in my particular project. So where I can get the important and the mean output what I want. So that is why, because as I consulted with the professor, they told very clearly that almost all 70% of the gas which will make your urinals and your commodes more smell is ammonia. And some 25% hydrogen sulfide will be there. So these two components we will get only in the 137, but hydrogen sulfide will get in other thing also, that is maybe I think MQ6 or some other is a, so that sensor also will get, but ammonia gas will get only in that particular thing. So that's why I'm telling that how we are going to relate the information descriptions from where you are getting the data and how you are relating. That is very much important. IoT service output itself is another important part of an information generated by an IoT system. This is very much important. So what is interrogating a sensor, whether it is giving a correct gas or means all MQ sensors which I can use. Whenever I will tell some smell means hey, MQ sensor I will take. Okay, if you take a MQ, which gas? What's the component? Really, I don't know that until I'll ask the chemistry professor. So that is important here. Virtual entity descriptions in general, which contain not only the attributes coming from an IoT devices, example, ownership informations. So that is also important here. And the virtual entity descriptions in general, whatever, who is the user ID, and authentication, API keys and all. Virtual entity association with other virtual entities. Example, room number 123 is on a floor 7. So here room number 123 is on floor number 7. How we are associating both the 7 and 123. Here you can see means why these things, sir, why you are telling all these things and all. When I will make an automated building, assume a smart building I want to make and all, these terms are very much important. Why? Because without human interactions, it should know. For example, I'll ask you, where is room number 123? Door should be opened or window should be opened, for example, assume. So my device should know that the 123 room is there in floor number 7. So this is the virtual entity associations, how we are going to use in one particular building. How many floors are there in floors? How many building means rooms are there in that particular room? How you are identifying a particular room? That things. The IoT service descriptions which contain associated resources, interface descriptions, and etc. So that in the case. Coming to the next. Information description, continuing with that, resource descriptions which contain the type of a resource, example sensor, identify associated services and devices. What type of sensor we should use, what is the service it will give, and whether my device is capable to hold this particular sensor, what I should do to connect this particular sensor to my particular device. That things is also important here. So device descriptions such as device capabilities. So sensors, radios means how many actuators it can connect and all. So that thing. So descriptions of composed services. So which contain the model of how a complex service is composed of a simpler services. Taking all simpler services into the consideration, I will solve a big composed service or a complex service. How it can be solved. IoT business process model. So after output means whatever a goal I achieved and all, taking that application into the consideration, IoT business process, how I can do, which describes the steps of business process utilizing other IoT related services. What are those? IoT virtual entity composite services. Security information such as keys, identity pools, policies, trust models, reputation scores, etc. will be followed in that. So that information is also important. Management information such as state information for operational functional components used for fault tolerance means fault and performance purposes, configuration snapshots, reports, memberships information. So management information is also important in the information view. Yeah. Back here, information flow and a life cycle. How information will flow and when information should be generated, how much time my information should be there, after what my information should be deleted. So always this depends, this makes your project how much success means it will tells your project performance. On a high level, the flow of information in an IoT system follows two main directions. Okay, so from devices that produces the information such as sensors and tags, keep it one side. Information follows a context enrichment process until it reaches the consumer application or a part of the larger system. And from the application or a part of a larger system information, it follows a context reduction process until it reaches the consumer types of devices or actuators. This is damn important. See what it means to tell you this. From devices that produce information, my sensor here, it's producing, assume the moisture level sensor, it's giving a moisture level. Okay, now once it's given a moisture level, information follows a context enrichment process until it reaches a consumer application. When it will reaches a consumer application, when the moisture level crosses 550, means once it is greater than a 550, that means that the dryness is more. Once the dryness is more, then I need further actions. So what happens when it crosses the 150, it will go more than a 150 and all, then automatically the information will comes to the consumer. Means the notification will be given to the user, the motor so and so is to be on one. Why? Because there is a dryness. From the application, again, there he presses a button. From the application or a part of the large system information, it follows a context reduction process until it reaches the consumer types of devices. That is actuators. The pump should on. When it will on, the notification, the dryness notification, moisture level value, dryness notification will be given to the user app. Once the user gets a notification, he will see. So pump 1 should be on. Why? Because dryness is more. So if user presses that button, then automatically it should come back to our device level. Why? Because my actuator is connected to the device as well, my sensor. So, but sensor, it's not directly working with an actuator. Meanwhile, the interrupter is there. Who is that? That is a consumer. So, consumer must know that he can also switch on and off that particular motor. So, that is a context reduction process until it reaches the consumer types of the devices. And you can see this particular figures here, A, B, C, and D, especially A, value and value container is there, it will go there. Where from value container, when it takes from a metadata, this is a value which has been taken from a sensors. The B, it is taking also from the metadata. I can say like this. Here, the best example I can say the value which I can take from the other things also, means some metadata where it will be also useful. Frequent data or production data, some data, ready data, it will be there. So you can observe, see now here, the service description will be given later on after this values which has been collected. So source description is there here and device description is there. From there, the service description will be given, and assume here the same the metadata whatever will be taken with the service. That's what it has been defined. It will comes to the D stage. In a D stage, what it is doing out, you can see the value container attribute is there, virtual entity will be created, and with that service description already, whatever the service have told, how the association will be there between the service and the virtual entity, that will be taken into the consideration. For this service description, where are the resources which you can use, so that will be taken into the consideration. In this way, the information process will be done. Meanwhile, I'm less known with the OMD. You may know more than me also. You can understand that clearly. Coming to the next, information flow on a life cycle. The enrichment process is shown in a figure. Devices equipped with the sensors transforms the changes in the physical properties of the physical entities of interest into the electrical signals. This we know the value which is. These electrical signals are transformed into one or multiple values. Figure A is telling that on the device level. These values are then enriched with metadata taken from metadata. I've told that information such as units of measurement, timestamp, and possible location information also you can take. That is in a B. These enriched values are offered by a software component, that's a resource, either on the device or the network. The resource exposes certain IoT services. What actually you have to do? IoT services to formalize the access to this enriched information. So that will become a C. At this point, the information is annotated with a simple attributes such as location and time, and often this type of metadata is sufficient to certain IoT applications or for the use in certain large systems. Further, support information such as associations between certain attributes and IoT services further enriches the context information of the virtual entity in a figure D that I have explained you. Now, information handling, how you can handle the information. An IoT system is typically deployed to monitor and control the physical entities. This we know already. To follow up the physical entities, to know about that, where the human interaction will not be there. So actually we need the entities. Monitoring and controlling the physical entities is in turn performed by mainly the devices, communication, IoT services, and virtual entity functional groups in the functional view. This we have know already. We know that. The presentation of the information handling is an IoT system assumes that functional components exchange and process information. Important. Assume one functional component is there and another functional component is there. This functional component will execute. It needs some information. It will take from either the virtual entity like that, variables like that. It will take, it will process. After processing of this functional component, some output will come. Maybe that output will be the input for other functional component. Like that, the exchange of the information will be there between the functional components. In many types it will be there. Based on a moisture level sensor value, the actuator should run. That's a one thing. Based on a temperature and the humidity, the sprinkler should on. Based on the carbon dioxide ratings or based on the splitting up of the values from one particular MQ135, how we can differentiate based on a values. This is a particular value, means whether it's a more or less, how the carbon footprints are there and all, we can analyze. Like that, the handling in an IoT system assumes that exchange and the process information. The exchange of information between functional components follows the interaction patterns below. Like this, it will be followed when it will be pushed, when the request will be there between A and a B. That is important. A and B are there. So A component means whatever is said, it will push a function to B. And A requests some other information, B will give a response to that. Now you can see the C here, the service of A, service of B, and depends on C. That is important. So how this is important here, SB, the subscribed thing, whatever is C is subscribed only with this, and SA is also subscribed. So a subscription of A, subscription of B is there with a C. So this is a notifies which is coming to the C. Now subscription of A and subscription of C to the B, whatever is there, that you are going to take into that, and B. Now if you go in depth of this particular thing, according to the textbook, you can see here push. And functional component A pushes the information to another functional component B, provided that the contact information of the component B is ready, configured in component A, and a component B listens to such information pushes. Right? This is important. Your B must know about A. That is what I mean to tell you, that the contact information of the component B is already configured in A. Why? Because A wants to push, means A must know the B, and B must ready to listen to A. That means B must know A. Request and responses. And functional component A sends a request to another functional component B and receives a response from B after A serves the request. Typically, the interaction is synchronous in the sense that A must wait for a response from B before proceeding to other tasks. That means I requested A should wait. It shouldn't go with any other works. You should wait until B response is there. But in practice, this limitation can be realized with parts of component A waiting and other parts performing other tasks. Now this makes the IoT project, means wherever human interaction is not there, until what time the A should wait. So this component A should wait for a response from B. Assume due to some other works and all, B will give a late performance. Then what to do? So this question arises. Subscribe or notify. Multiple subscribe components, that is SA, SP, can subscribe for information to a component C, and C will notify the relevant subscribers when the requested information is ready. So assume that A is waiting, B is busy. C is also a subscriber of a components of SA and SB. C can also interact. Means C will notify the relevant subscribers when the requested information is ready with the C. So that you must know. So this is typically an asynchronous information request, after which each subscriber can perform other tasks. So it will become asynchronous. It's not asynchronous here. Why? Because A is not requested C. But even though A is not requested C, C knows about both A and B. And because of that, C is free, B is busy with some other work, C can also give that information what actually A wants, that response. So nevertheless, a subscriber needs to have some listening components for receiving the asynchronous response. That means for listening component should be there always. This is very much important. A separate, I can say that transmitting and receiving. Transmitter or receiver, that plays a very much important role. So one receiver should be there as an antenna. It can listen to other things also. So publish, subscribe. But its subscription is very much important. I can't listen to anybody who I doesn't know. No, then I will be open for an hacking. Somebody can hack my information and they can. This means they can damage that particular device. But this is very much important, that the subscription is very much important. What is this? In the publish subscribe, also known as a pub sub pattern, there is a third party component called the broker B, which mediates the subscription and publications between the subscribers, information consumers and publishers. So a third party will be there always. He will tell, yes, you are allowed to our group, and your subscription certificate is so and so, and you will be identified with this particular MAC number, or this particular identification unique number will be given to you. With that, you are identified. So that thing can be done. Information view. In that information handling, subscribers such as SA and SB subscribe to the broker about the information they are interested in by describing the different properties of the information. So yes, they can do that. Means I need a subscription of A, I need subscription of B due to so and so reason. Why? Because I am always linked with their functional components interrelated with me as an SC. Yes, so you need a subscription of that. Next one is deployment and operational view. This is the last topic of this particular unit. The deployment and operational view. Now everything is ready with us. Functional view is ready. IoT reference model we have studied. Information view is ready. Everything is there with us. Now we should go for a deployment of our particular project. In that, we have to see two things. One is a deployment and another one is an operational view. Both the views we should see how a deployment should be done and how I can, after deploying, how I can make my project to operate. The deployment and operational view depends on a specific actual use case and requirements, and therefore we present here on a way of realizing the parking lot example seen earlier. We'll take the same example back here, and it is by no means an exhaustive or a complete example. So we'll take the same the parking slot example, whatever is there. Now we'll discuss in depth that in reality, if we deploy, what are the constraints or what are the extra things we should take into the considerations. That we will see, and that model will take as an example. Next, figure depicts the device view has a physical entities deployed in a parking lot as well as the occupancy sign. So that you know already. I have told you that there will be 16 parking slots will be there. What are the physical entities? Here, just a parking slot, whether it's filled or not. That will become a physical entity deployed in a parking lot, occupied or not. There are two sensor nodes, assume just for a sake. There's a 1 and a 2, each of which are connected to 8 metal car presence sensor. The two sensor nodes are connected to the payment station through wireless or a wired communication. That is, assume in the sensors connected to the 8 metal, it can be metal, it can be connected or car presence to whether car is there or not, what time the car is there or not, car is removed or not. For that, I will keep an IR sensor there. Ashish project you can take into the consideration. So Ashish, how he is doing, Ashish and Sai Siddharth. So how they are doing the project. When IR registers, they will keep when body is there, they will think that it's there. When once it has been removed, it will tell that particular plot is vacant. So here two sensors they are using. One sensor is for that, and one sensor, assume two sensors connected to the payment station through wireless or a wired communication. The payment station acts both as a user interface for the driver to pay. Means I can say like that, assume a payment gateway will be there. So it should act two ways. From a sensors, whenever the parking slot it has been taken out, the out time it should know automatically. So that is the one way. And whenever a driver comes there, the driver to pay means either card, what payment, what type of a payment he will do and all. Get a payment receipt as well as communication gateway that connects the two sensor nodes and the payment interface physical devices. So displays, card, credit card slots, 100% it should be there. Coin note, input, output, etc. With the internet through wide area network. 100% the payment system means we should connect it to the other credit card, whatever is there means we need an internet that should be connected via WAN. So that should be there. The occupancy sign also acts as a communication gateway for the actuator node. Note down here the occupancy side, that means IR register, what means sensor what we have kept, either it will tell you either occupied in the parking slot or parking slot is free. As a communication gateway for the actuator node, display of the free parking spots, and we assume that because of the deployment a direct connection to the payment station is not feasible. How either the slot is free or not, parking slot, either parking slot is booked or not, how? So we assume that because of the deployment, a direct connection to the payment station is not feasible. Example, wired connectivity too prohibitive to be deployed or sensitive to the vandalisms. The two main applications connected to this management system are human user mobile phone applications. They can book online, as I told you in a previous class. While leaving a home itself, they can book, and parking operation center applications. That means in a parking stage, now how many are free? If you book from home itself, how to book that? Now your object is not there. Your IR sensor, it comes in a second way now. So how to book that? Parking operation center applications, we assume that the parking operation center manages the several other parking lots using a similar physical and a virtual infrastructure. So both, it should take a physical infrastructure and as well as a virtual infrastructure. Now, taking that into the consideration, now you can see this is an activity diagram which you can take, model which you can take, and how this particular sensor 1, sensor 2 is the area. You can see from this IoT services which you can take out to 11, 18 or 21 to 18 like that. So, and it is connected to the payment station service which is there, and gateway node will also be there with the sensor 2 actuator node. Occupancy it's going to tell you. Sorry, coming to over here, parking lot management services, payment business process service, virtual entity service occupancy sign, virtual entity service slot from 1 to 16, either it's booked through application or not. Virtual machine N, so virtual machine 1 it will start here. Application number 1 phone, and application number 2 remote operations and management. Either from my system I can book it out, either from my mobile also I can book it out. So both the ways I can book. Then it comes to the role that either way, seeing a screen display I can book, either seeing from mobile itself also it can be booked. Then how the occupancies you can manage. So that is an important thing which will be there here. So the figure shows two views superimposed, two views. The deployment and functional views for the parking lot example. Starting from the sensor devices as seen earlier, sensor node number 1 hosts sensor 11, 18, representing the sensors for the parking spots 1 and 8, where earlier sensor node hosts resources 21 and 28, representing the sensors for the parking spots 9 and 16. We assume that the sensor nodes are powerful enough to host the IoT services. Yes, services we have numbered it 11, 18 and 21, 28, representing the respective resources. The two sensor nodes are connected to the gateway device that also hosts the payment service with accompanying the sensors and the actuators as seen earlier. The virtual machine, now you come to the virtual machine, your mobile way of working. The virtual machine hosts the communication capabilities, virtual entity services for the parking spots 1 to 16. Virtual means from mobile itself I'll book, vehicle will not be there. Until I'll come, it should be booked. It should not be allocated to others. The virtual entity services for the occupying sign a payment business process that involves the payment station. While booking itself, I will pay. Either the payment management should also be done. Payment station and input from the occupancy services and the parking lot management services that provides the exposure and access control to the parking lot occupancy data for the parking operation center and the consumer phone applications. This is important. That is, so and so parking slot I have booked, even though whatever the IR sensor is there, vehicle is not there. So two ways here, means two things are imposed. Then from mobile it is booked means it should take care, that also. So that things will be taken here. Coming to the next slide. As a reminder, the virtual entity service of the parking lot uses the IoT services hosted onto the sensor nodes and performs the mapping between the sensor node identifiers. So whatever the services it wants, I will identify the sensors, either it's a virtual entity sensor, either a physical body, virtual that services, how the services should be handled. So in this way, the services offered on this parking spots are to be read the current state of the parking spot to see whether it is free or occupied. The virtual entity corresponding to the occupancy sign contains one writable attribute, the number of free parking spots. So how many now free parking spots are there, including the booking spots also. Of course, for the operation of the parking lot, a number of the other IoT related services would be useful, such as historical occupancy data. Already how many vehicles are there, how many free, how many are booked. Two ways here. On which machine learning algorithms would support the operator of the parking lot in making decisions about planning and charging. So this is another one important thing. Usually from last 4 to 5 months, what time the vehicles, which vehicles is regular, what time they are taking out and all. For example, assume when I try to book in all through the app, all slots are booked. What is the time it will be free? If I ask the question in another 20 minutes or another half an hour, so and so parking slot will be free. You can book in advance. So that things will be taken. How? You can predict from historical data. Figure shows an example of mapping of an IoT domain model and functional view devices with different capabilities. So that figure also you can see, and the cloud thing, whatever is there, I will explain you in a next coming class. Just I'll stop the sharing. Another 1 hour, I'll complete this particular unit. Answer your challenge now. Aditya, I think same persons. Last class, those who are not attended, if anybody are there here.
Sir, I am attended, sir.
Last class you are not attended?
Attended, sir.
No, I'm asking last class, those who are not attended, attending only this class. Anybody are there? I will take same attendance, that's why. Wait to call again and again.
Sir, 25, sir.
Saket. Why Saket? What is the problem? You are not attending IoT classes? Huh? Saket. Listening?
Yes, sir.
What's the problem?
Yes,
Hey, what's the problem?
sir, last I had interview, sir. I was preparing for that.
Any others?
Sir,
Sir,
30.
57, sir.
ಪ್ರತಿಮಾ ಇದೆಯಲ್ಲ ನೀನ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್
Yes, sir.
ಮತ್ತಿನ್ನೇನು
ಅದು
Next.
ಕೇಳ್ತಿಲ್ಲ ನಿಮ್ಮ ಕೆಳಗೆ.
ಇಲ್ಲ ಕೇಳಿಸಿದೆ. ನೆಕ್ಸ್ಟ್
57, sir.
Manish, you are not there in last class. Why? Again, you are absent. Others, quick. ಹೇಳಿ ಅಷ್ಟೇನಾ? ಇನ್ನೆಲ್ಲರೂ ಇದ್ರಾ? So according to the attendance of previous, I'll take.
Sir, ಅಪೂರ್ವ.
ಅಪೂರ್ವ. ಯಾಕೆ ಅಪೂರ್ವ? ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡಿಲ್ಲ, IoT ಬೇಡ ಅನ್ನಿಸ್ತಾ?
ಇಲ್ಲ ಸರ್,
ಮತ್ತೆ
ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತು ಸರ್ ಅದಕ್ಕೆ.
ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ. ಇಟ್ಸ್ ಆನ್ ಕೇಸ್ ಸ್ಟಡೀಸ್, ಎಸ್ಪೆಷಲಿ ರಿಯಲ್ ಟೈಮ್ ಕೇಸ್ ಸ್ಟಡೀಸ್. ವಿಲ್ ಡಿಸ್ಕಸ್ ದ ಇಂಡಸ್ಟ್ರಿ ಆಟೋಮೇಶನ್ ಅಂಡ್ the last unit, industry automation and the real time world constraints, technical constraints when we deploy the project, and as well as the building automation is there. That's a good case studies are there. So that case studies also, it's very good. We will discuss that in the last unit. Just another 1 hour, the fourth unit is there. After that, I'll tell you what are the important questions and all. Okay. Just I'll stop now the recording. Stop.